If you were in space, and accidentally took off your helmet, what would happen? Don't worry, you wouldn't instantly freeze into an ice sculpture like in the movies. Instead, your body temperature would be maintained for a while. If you were hit by the sun, that part of your skin might even get scalding hot. Space is a place of extreme hot and cold. The shadow side is hundreds of degrees below zero, while the sunlit side can be over 100 degrees Celsius. This extreme temperature difference would certainly be an unforgettable experience. Of course, this change isn't instant, because heat transfer takes time. But what would actually kill you isn't the temperature, it's the pressure. We've lived on Earth for so long, we're used to atmospheric pressure. You might not realize that a single atmosphere of pressure is squeezing you from all directions, every single moment. This pressure isn't tormenting you, it's protecting you. It keeps everything in your body where it should be. The gas dissolved in your blood stays put, and all your body fluids are well behaved. But in space, that pressure suddenly vanishes. In an instant, it drops from one standard atmosphere to zero. Everything inside your body wants to escape. The gases dissolved in your blood start furiously forming bubbles, like opening a shaken bottle of Coke. These bubbles will clog your blood vessels, especially the tiny capillaries in your brain. Circulation collapses almost instantly. You might think, what if I just hold my breath? Sorry, that's useless. It's not about the air in your lungs, but the pressure differential is gone. Your respiratory system just shuts down. Oxygen can't enter your blood, and carbon dioxide can't be expelled. Your lungs won't explode, but don't count on them to save you. The whole process takes about 15 to 20 seconds. Then you'll lose consciousness. In less than 90 seconds, your brain will suffer irreversible damage. In about 2 minutes, you're basically gone. And during this time, your body will swell a bit because the internal pressure is trying to expand outward, but it's nowhere near the movie exaggeration. Your body won't explode, it'll just look a little puffy. It's worth mentioning that a similar tragedy has actually happened in history. In 1971, the Soviet Soyuz 11 spacecraft carried 3 cosmonauts, completing the first ever space station mission in human history. They stayed on Salyut 1 for 23 days, setting a record at the time. Everything was perfect until the moment of return to Earth. After separating from the space station, a tiny exhaust valve malfunctioned. This valve was so small you might not even notice it, but its failure was fatal. In a few seconds, all the air in the capsule leaked out. No explosion, no fire, no violent commotion. When the spacecraft landed and the hatch was opened, the 3 men were still in their seats, their positions unchanged. They looked like they were sleeping, but they had no signs of life. The cause of death was complete depressurization. This accident shocked the world, making everyone realize that space's greatest enemy isn't the cold or the darkness, but the invisible, intangible lack of pressure. A no-pressure environment is like an unseen assassin, silently taking lives. A centimeter-sized valve failure could make 3 highly trained cosmonauts lose everything in an instant. But there is one more bizarre case in history, a survivor's story. In 1966, at NASA's Johnson Space Center, an engineer named Jim LeBlanc was testing a new spacesuit. The test was being conducted in a vacuum chamber simulating the space environment. During the test, the pressure hose connected to the spacesuit suddenly came loose. In an instant, the pressure around him dropped close to zero. The camera recorded the whole process. LeBlanc started to shake, reaching for his helmet, and then, 14 seconds later, he collapsed. He completely lost consciousness. Luckily, a technician reacted incredibly quickly, rushing into the vacuum chamber and restoring the pressure after 25 seconds. Those short 25 seconds saved his life. LeBlanc became the only person in human history to have experienced vacuum exposure and lived. He later recalled that before losing consciousness, the only feeling he remembered was the saliva on his tongue boiling. In a vacuum environment, the boiling point of liquids drastically decreases, so the saliva in his mouth immediately started bubbling. He said the sensation was weird, but not as painful as expected because before he had time to hurt, he had already passed out. This case provided scientists with incredibly valuable first-hand data. It proved one thing: in a vacuum, losing consciousness is very fast, but if pressure can be restored within a minute, it is still possible for a person to survive. Of course, that possibility is predicated on good luck and someone being able to immediately administer aid. In actual space, both of those conditions are basically impossible to meet simultaneously.